sort of general presentation we've had since, what, 2017. So we're kind of missing out on that personal touch, which is fantastic. So it's great to see you here. And I know there's about 100 people on Facebook, is it? Yeah, whatever it is, out there as well. And they wanted to know why we didn't start at 10. But anyway, just waiting for a couple more people. So great to see you all. A few familiar faces. What we are really doing today is launching a product which it's almost like, why did it take this long to get to this level of technology? It's almost something that we would expect that would have been available a long time ago, but we're glad that it is available now, and we're just going to talk about the features, the advantages, and so on of the Prepreg. So just to go through a short program, we're going to present to you the unique properties of the Prepreg. Then Brian is going to show you how easy it is to lay up. Also, what Brian has done, he's prepared a tool that's in the oven running right now, curing, that we're hoping to demold once the presentation is done, and then you can see it live. So it's in the oven in the back there. We're going to have a question and answer session, and I do believe there are people that would also want to ask questions on Facebook. And then one of the little bonuses that we thought we'd just add in is there's been new developments in fusion technology, and Brian is going to present that to you as well. So we've got a little tool in the back there, and he can show you that. So what are we talking about? The product is called Enduredge NT350. It's a novel epoxy-based Prepreg technology. Okay? It is termed as a hot melt, and we're going to go through why the difference between perhaps a hot melt and a thermoplastic and so on a little bit later or through the presentation. As far as we know, and Next Technology is the marketing company that takes care of the rheology. So it doesn't lose tap, it doesn't lose shelf life, and ultimately it doesn't lose mechanical properties. Okay. So that in itself is very unique. The second, probably most significant property is that most prepregs and most high-performance prepregs require autoclave processing. This product simply needs vacuum bagging and a very hot oven. And we'll go through the rheology a little bit later. Okay, sorry, we'll move a little bit ahead. Another very significant point is a lot of prepregs require debulking. And the reason you require debulking is that you have less voids, you have a highly consolidated laminate, and finally you get a very low void prepreg. So the debulking process, we're also going to show you, and we're going to talk a little bit about it when we lay up, but the debulking process is very simple, and this is to do with the way the resin is applied onto the fiber. Okay. And as we said, near zero void laminates. This is not 100% true. It's not completely void free. But if we go through the post-curing process or the curing process, and we follow and respect the ramp-up process, you will get that. And we've actually done a fair amount of products already. We've learned a lot in the last couple of months, and we're finding it, as we're processing it more and more, we're just finding that's really, really a unique product. Okay, then you say, well, if there's no autoclave and it's just vacuum bag oven, surely there is a loss of properties. Not at all. So please have a look at the data sheet, go through those mechanical properties, it's powerful. we are talking of a very high performance pre-trigger. Sorry, things jumping around a little bit. I'd like to perhaps talk about the most important thing that we've discovered. If you look at the graph up here, the sort of golden hour that we have discovered is really the ramping up. Okay, that's gone.
Just bring it up here, full screen.
So the ramping up, we have found, is the most critical part of this process. So Brian has done tons of laminates, and we have found that if you don't respect, if you either heat it up too quickly or too slowly, you're not going to get that perfect finish as we have here. So it took us a little while to get to that, but once we've got it right, it's just consistent all the time, and it is a perfect laminate. So the whole idea is taking it up at 1 to 2 degrees until you get to 80, hold it there for 15 to 30 minutes. So plies less than 10 plies, you require about 15 minutes. 10 plies plus, it will require quite a little bit more. Okay. You hold it for 130 for 60 minutes, and if your TG and your mechanical performance is okay at 130, you don't have to then post-cure it. If you want a higher TG, if you want to achieve greater mechanical properties and higher thermal properties, you then take it up, you ramp it up to 180, hold it for 120 minutes, and then cool it down. Okay. So I think, Brian, what you can do is just go through, I just want to show you the ease of how it is applied, because you would think that if it isn't refrigerated and there's no tackiness or anything, but we're going to put some samples, throw them around, and you can feel the tackiness. There is some tack, and Brian is then going to show you how to apply it. So can you change that?
So I'm going to be playing with this stuff, and we've had it for a while now. Like Joe says, that golden hour of warming it up, getting the tool up to temperature, just continue to allow it to climb until you get to when you plateau off or allow to cure. Because this is actually a higher temperature resin. So it wants to see more heat. The first sample I did only cured at 120. And it didn't really work. I had to take it to 140, and at the end I've sort of do all my samples and passes around. We're looking at about sort of 150 TG, or 150 in the oven for, let's say, what is it better? It's got less imperfections on it. So, yeah, it's like a normal prepreg in the sense that it has the right amount of tack. It's like, some prepregs are very tacky, some are not tacky. This just seems to be just nice. I've got a pre-coated surface here. You can see there. You need strong fingers, so stand closer.
And you got 9.
Don't buy from us. So you can see there. This tool is really cold now, so it'll stay there. I'm making 2 corners in that to use your. This is just a bit of polyethylene that's been shaped to what I needed to. Let's see what's there. And with all things, you got to be aware of bridging and stuff like that. So you see those parts I sent around. Yeah, you just need to be really good with your getting into all the corners. putting a little bit of an example of.
So Brian couldn't have picked a more difficult tool to demonstrate it. So,
Yeah, I thought I
so
saw
very sharp corners.
Yeah, the resins also. Just busy going down.
So if you wanted to achieve a slightly higher tack, you could use a soldering iron or a little heater gun. Not too much, obviously, because I'll explain to you why you don't need to debulk. And maybe, in fact, while it's, you want to say something about what you're doing?
Yeah, so what I've done here, basically I've got a half round, you can see. So there's a very sharp edge on this side. And I'm just adding a bit in there now. We'll do this way. I put it on top of the south. Okay.
So, Bertrand, you will recognize the tool.
I've seen it.
Somewhere, eh?
Where's the rest of it that they
It's at
unbolted thing?
No, it's at Enduredge.
Okay.
So we picked the most difficult part. So whilst Brian is demonstrating that, I just want to explain why it is so unique. If this is your woven fabric, sorry, just expanding it a little bit. The technology of applying the resin onto the fabric is through what we call, what determines a hot melt process. Okay? So the placing of the resin seems to be where the intellectual property lies. Because if you look at it carefully, and we're going to take it around, the resin sits on the fibers like that. And if you look at it in the light, you will actually see there is almost like a little gappiness to the product. Okay, and that's deliberate. And even in some fabrics, let's say like a plain weave, you actually even see it more. And it's quite deceiving because when you pick it up and go, oh, this is not going to give me a good surface finish. Well, here's the results. The surface finish is, yeah.
It's very gappy, but sure.
So basically what happens is the resin technology, the way it's applied, creates these paths. And for this reason, your debulking is not that critical. Not like a traditional prepreg where you have to apply a lot of pressure and make sure that the dwell time is correct, that the resin flows. This creates its own path. So when we talk of 10 plies plus, that's quite a hefty layer. And you don't need to do one layer debulk, do another layer debulk. And that's the beauty about this prepreg. So the fact, sorry.
What is the weight of that cloth?
This one I think it's about 200 grams per square meter.
No, that's like a cloth and resin.
Pardon?
The cloth alone or cloth and resin?
No, the cloth alone.
The cloth.
Yeah. And I think this particular one is, if I'm not mistaken, 38%. Yeah, if I'm not mistaken. I'm not sure which this one is in particular. Again, if you look at what Brian is demonstrating here, this is a complicated tool. This is a difficult tool. It's got sharp angles. It's got very, very tight radiuses. And you'll see it's relatively easy to apply. And isn't it amazing that you can go and pick this off the shelf and do a part very quickly? You don't have to fire up an autoclave. I mean, these are really, really significant advantages to this prepreg. Is that you can take a conventional oven and only adaptation that you have to make to that oven is ensure that you can ramp up at the desired temperatures. So think about the cost of firing up an autoclave versus firing up an oven up to 130 degrees Celsius.
but not just that. I mean, we played a lot with the thick sections on match metal tooling, and you die on the
Yeah.
bulking kills you, and it's so difficult to get right this way.
Yeah.
There's no guarantees.
Yeah, pretty much. Sorry, Carl.
Are you offering any other reinforcements, glass and aramid and stuff as well?
For the moment, I think for the launch, we chose probably the most popular carbon fiber, which is a 2x212 to 100 grams. This is new technology. We just sort of post-COVID. There's a lot of uncertainty. We have stock of this particular product, but to answer your question, absolutely yes. There is a range of glass, there is a range of carbon fiber, but we've really taken the most common product that Next Technologies have produced, and this is it. And it's a fabulous product if you're doing carbon, but we do understand that there will be other requirements like unidirectional glass, and I think we've got an inquiry on.
They were talking about UD. Heine was off there.
Was it you are, yes.
And then they did say that they were going to have it available in the near future. So
yeah. So please let's be mindful. This is also a relatively new product for Mitsubishi. So it's not only we've caught it quite new, and that's the exciting part. Is that we're up with the rest of the world. So this product is available, and we must take advantage of it. I mean, imagine now producing parts without an autoclave, without expensive storage in a freezer.
Importing it without dry ice and not having to keep it.
Thank you.
Yeah.
Exactly.
Because the autoclave I can live with, but the extra $250,000 worth of dry ice,
Yeah.
it really hurts.
No,
Because you can't,
absolutely does.
you get nothing for it.
Okay, you stole my little thunder because that was one of the things that now we could offer. No, it's perfect, 100%. Previously we would have to place the order, let's say with Hexel or Gurrit or whoever. They would have to produce it, and then that, as you know, is not a quick process.
22 weeks lead time.
And now, even worse. As we sit here today, it compounds. So not only is the lead time, and then do they have capacity? And then when we have to bring it in, we either, if it's bulk, we have to bring it in refrigerated containers, or dry ice. The dry ice component is, I don't know, maybe Nigel, you can expand on that, but it is massively expensive versus the value of the product. So the beauty about this is I can pick up the phone, or Isabel can pick up the phone, and say, right, have you got this in stock? Because you don't have to freeze it. They can have it in the shelf. So as the product gains popularity, I think you're going to find our lead times are going to get shorter. Again, this is quite new. We are probably one of the first sort of customers outside the United States to grab onto this product. So it's also, as we progress, we'll be able to tell you.
What's the modulus like on the fibers that you have now that you're using?
It's all on that. The very product that we have. So I don't know offhand. That's the data sheet on this very product that we're using here.
Okay, and then if I were to tell you I need a higher modulus and so on, I mean, could you just bring it in?
It depends. I can't answer. I can't give you a straight answer on that because they would be running for other companies, for other customers around the world. So it depends what they have. But yes, I think they can. We just started with. Sorry.
You should be able to.
You should be able to. I don't see an issue there at all. But I can get back to you on that one. You tell me what you need and put the question out there.
As high as possible before I need to start signing non-proliferation.
So I was going to say, it depends if it's allowed to come in or not, the actual fiber.
Yeah. So at the moment,
This is an export license for it.
This is a toughened Prepreg. This has got seriously good mechanical properties. We're quite blown away, by the properties at this point. And what we have done is we don't just bring in the product and then launch it and say, oh, wonderful, don't need this, don't need that. We actually have processed this product and we have discovered a lot of things. Brian has done multiple products. Where's the other? That Carl's tool.
Carl's tool.
The part. So,
the parts are around somewhere.
so for example, Carl, kindly enough, loaned us this mold. The first part that we did, we were super impressed. Okay, we went, wow, this is something fantastic, and we got the rheology completely wrong, didn't we? So,
this is actually the first one I made. The second one
was this? Oh, this was the first one. Yes, it was.
The second one.
Okay. So that was the first one. The second one was infinitely better, and that's our second run. And subsequently, we've just been producing really, really good quality parts. So, is there a learning curve on this? Yes, possibly your first part, and then just going back to that rheology curve. And this is what Brian has found, is that it is quite critical to go through that phase because there's two important things. It's the debulking, it happens naturally, and secondly is the resin flow. So it's starting to infuse into the fibers whilst you're getting that debulking process going. So hugely advantageous.
Yeah, I think they got it right because it's a high TG resin essentially. With a longer gel time, it's enough time to debulk it, so it just flows properly.
Yeah.
It goes like butter. Condensed milk. Good stuff. It gets hot. Yeah.
Have you gone through the full rheology? Does it, like you said, butter and honey, does it turn into water at some stage?
We don't
Gas
know.
even better.
Because that's also a problem. If the stuff turns into water to contain the resin, if you're doing thick laminates and you've got liters of water-like viscosity that wants to
Absolutely.
go into the pipes and do everything.
100%.
Lots of good pop.
If you look at the wetness in the back, that indicates to me that it doesn't go to water. If it did, you would probably see a really good surface finish, but quite a dry laminate in the back. So this indicates to me that they got the rheology pretty damn right. And really the stiffness, this is what Tistula is on that.
Actually, I think 4 on the bottom.
4 at the bottom. Oh, okay. And 2 on the top? Yeah. So this is stiff. This, it's got the right ring that we all want out of a carbon laminate. So really, if we just recap, let's look at practicalities of the product. To bring it in is relatively inexpensive. You don't have to worry about a repacker, putting it into dry ice and all those wonderful things. Your transport costs come down fairly considerably. And that's a reality for us. And as you're all aware, what's been happening lately, post-COVID, and all the challenges that we have with freighting. Freight is now a major component for us in everything that we do. So we are a net importer. It impacts us and thus it impacts you very, very badly if we don't get the right mix. So if we don't bring in bulk containers, if we break bulk all the time, it's just going to cost. So the cost of bringing in this prepreg is as if I would bring in a normal dry fabric. It's as simple as that. Okay. The fact that it can sit on your shelf for 12 months plus, that's a big bonus. Okay. So there's no taking it out and defrosting it, because as it goes through that process, if you don't get it fully down to room temperature, there is the possibility of absorbing water. So water absorption is another reality that gets removed from this. Then, if you want to make a quick part, you can go to the shelf, cut it up, lay it up, zap it into your oven, cool it down, off you go. How far is that, by the way?
Still got a government. Another thing I learned is that the release film that was put on top, it's definitely a non-perforated with no holes. and I've got a stitching needle, and like the smallest, it's just a pin prick. So on this little part, not perforated, release down, I'll just put down one hole there, one there, and one on each side, and that was more than sufficient. And even just with a pin prick, you'll still get about a bleed from about that much. So it does flow. The first samples I made for these samples, we used P6 release form. Disaster. Just too much resin came. We still got it. There's still a good proper carbon sheet. It's pretty pinhole richer in the surface. Just and really, that's why I did that test again to show you guys. We take it out. It was just like 5 or 6 little spots. Ever so slightly, not on it. Just barely.
So again, these are just things that we are going through that we will share with you as we go along. Okay, it's not a quick fix. Here's the product. Off you go. You learn how to work with it. No, we will give you that right support all the way. And as I said, Brian's had several months now to to play around with this and get a good feel, so we can give you the right information confidently, that you can process it relatively quickly.
Brian, just a quick one. Have you tried just after the first layer, just debulking for 10 minutes or 15 minutes?
It's very gappy, this material, if you look at it in the light.
Yeah.
It's completely gappy. The big thing of the first layer is to get it right on the surface of the corners. Because in these 2 samples I made, this is the first one. The other one has got a smaller bubble on one side. So this, it's the same as any other prepreg. And once to bridge it, you're going to make it more. But we can try. This tool works well. See if there's any difference. But I mean, that's a good. Okay, gone yummy.
So yeah, you're not left alone. We have a lot of technology. We've learned a lot through this, and we will continue learning. But for us, this is one of those products that, well, why hasn't it been around before? Well, hello, it's here. And the advantages for all you composite processing customers out there is it's enormous. It saves a lot of money, a lot of processing, a lot of time, a lot of headache. You're not a Formula One team that has got $5 million worth of prepreg in a freezer and you can just go and pick them up. But now you can almost compete in that environment because you're going to have a 50 square meter roll that can produce a part at a fraction of the cost that the big autoclave uses. So big advantages, really, really big advantages. I don't like to talk about pricing, but obviously that's on your mind. At the moment, as we stand here, this is about 950 Rand a square meter. Oh, sorry, linear meter, 12.27 wide. And that is pretty bloody remarkable. The technology is super. The savings that you're going to have in processing are phenomenal. And it's not out of reach of conventional prepreg, so this is kind of really good.
Remind me, Joe, what is the shelf life of this? In and out of the fridge? I mean, you can put it in the fridge.
You can, it's not necessary.
Yeah, but does it do anything to the shelf life?
No, it doesn't. They don't recommend it. Keep it at room temperature. Absolutely, it doesn't need refrigeration whatsoever. You can keep it in the shelves. Don't go above 30 degrees Celsius or don't go into the 40s because that starts changing the rheology. You probably find it gets a little bit more tacky and so on. So just respect that it's at room temperature. Room temperature is 25 degrees Celsius. Don't go too high. Yeah.
Shelf life?
Shelf life?
Yes.
It's 12 months plus, so it can be between 12 and 24 months. That's what we believe. Again, Nico, this is quite new technology, so we don't have all the answers, but we pretty much. I don't think they've kept it in the shops for 24 months yet next. Yeah.
And then the susceptibility to humidity. Obviously, if you leave it outside, it gets exposed to all kinds of other environmental aspects. So,
in its state, in its natural state, I don't think. And again, I'd have to get back to you because I do know all prepregs absorb moisture. Okay, even when they're cured, they probably absorb moisture. But this is low moisture absorption prepreg, as far as we know. In terms of storage, you know what? Keep it in a plastic bag. Not even aircon room. No, it doesn't even need aircon room. But you don't want to have 100% humidity and so on. But it certainly doesn't behave the same way as a frozen prepreg. You take it out of the freezer, that is susceptible to moisture. You don't have those problems with this.
Put it in a plastic bag with these moisture.
Yeah. Yeah.
this
Perfect.
When it gets supplied, it does get supplied with some
this
stuff,
Yeah.
so it will
Chinese stuff.
No, it comes out of the States, not China.
From China.
Wireless States.
And then, have you had it on a cutting machine?
On a fly
For
cutter?
fly cutting.
No, not yet.
So,
but
I was just thinking about, obviously, the tack level, the backing paper is going to stay on the part. If you do quite an intricate kind of cutouts.
if you feel the tackiness, I think it will. And I know out of the States, for sure, they've already done it. I mean, they don't do like we do. They fly cut it. So
We bring some material, we just run a program we have.
we've issued quite a few meters. We still can issue a few samples. We still have a few samples left, which we're happy. If you want to play around, we will happily donate you some.
I need some rim material, some category.
Yeah, I was saying
And then-
on the fly cutter, chuck a program we have on the fly cutter and see what it does.
No, what we can do, a couple of meters, no problem, as long as it's not 50-meter rolls or something.
Yeah. No, just for the little, we're not running any of the stuff that we used to run, so as small as possible, just to see how it works on the machine.
Yes. Yeah.
And then also based on the fly cutters, how printable is the surface? Because obviously,
There's a pre-packed bag. I've got this little blockade as part of my onboard resin track here. So over time I've just developed that, so when you've got to chuck the right amount of resin in this bag, the excess is just enough to fill up the correct release. Works out.
Yeah. I didn't believe you that you.
It does work well. I'm going to set this up quickly.
Okay. Are there any questions around this? This is really Brian's domain, and we've been hugely successful in creating these silicone bags for our industry.
Epoxy resin.
Epoxy resin is a bit more aggressive, and they don't last as long as polyesters. But I mean, in the early days, also what's happened, Stan, is the silicone technologies improved quite dramatically. So it's become a lot more resistant, but still, you will not get the volumes. I mean, you're talking about 1,000 parts. We had a very high and complicated production out of Global Composites in Pietermaritzburg. And the part was big and it was complex, and the bag was manhandled quite a lot. What was it, Nigel, about 600-700 parts before we had to replace the silicone bag, and I thought that was really great. That was, what, 7, 8 years, 9 years ago?
Polyester, isn't it?
Polyester, yes, polyester. And today, the technology, the silicone technology has improved quite dramatically. It's a lot more chemical resistant. The tear resistance has improved because of the way we lay it up. They've also become lighter, so the silicone bag has become thinner, more chemical resistant, more durable, and yeah.
So, Joe, what can you expect on a very aggressive resin system?
On epoxies, it kind of varies because the epoxy technology, the hardener technology can vary quite a lot, and certain amines attack the bag a lot more than others. So if in the worst chemical attack, I think it's probably epoxies followed by polyurethanes, followed by polyesters and vinyl esters, and then polyesters.
And then the life, I mean, it doesn't matter, it is what it is, just for, you cost it into what you do and do your best, but I mean, what are you talking about? If the lowest one is 2,000 cycles, then the highest corrosive one is about 10% of that?
Prime 27, then the one is very aggressive. I've used the part where I've only got 10 pulls, and then it's gone white already.
So 5%, if you're going from super
Hard to
super
yes.
aggressive to the more normal stuff.
Yeah.
I
think it's 5% is probably accurate, 5 to 10%.
Yeah.
On highly aggressive
Look at it,
environments.
it's not one's fault, it is what it is, just to know. If you're using it there, then just know.
So LR30 is out of the question.
No, funnily enough, LR30 would probably be a little bit better in terms of chemical attack versus Prime 27, for example. LR30 with the SLC range is not that aggressive, but it's not a resin system designed for infusion.
Yeah, I know.
So
I infuse.
yeah, but still you would infuse it. If it's impossible to infuse, you would infuse it.
Well, it's not impossible anymore.
It's not impossible anymore.
Okay, I'm going to show you how this. Okay, I've got my vacuum into at the bag now, and then I've got these very fancy little clips here, which is a washer over the pipe. Now I can activate. Which one am I activate? Let's see. And I don't know if you can actually see. You see this vacuum through there? It's got a dent in the
So it's not collapsed.
collapse it. And just see it?
Yeah.
Now that is with in this configuration that you can actually see that when I've got it in the same vacuum, and that obviously doesn't do that, it just becomes neutral. But if you have differential vacuum where less into the actual part and more into it, you can actually create that. And the good thing about this, I'm going to pour the resin in, and I'm going to activate this one first, and then I'm going to activate this one which goes over the edge. So you can turn this on and off as you want to create the flow moving around under the bag. You can switch them all on and just hope, or you can actually direct. I can create this one on its own. So just to suck that side. So the big trick with this is to actually put a part in and put in normal soric lines, spiral line. Actually, just get an idea where you want the flow to go, and then you actually make the bag and make that. I wouldn't just go blindly make a bag and just place these half moons and hope that they're right. It could be right, but you could be. Good chance to be wrong, especially on the complicated parts.
Ron's mix.
Brian, you can let's just chuck mesh under the bag as well, man.
You can. Yeah. Now you can play around so much of this stuff. If you see a problem that you added in by default, you correct it. So I've got those. Let me just see the washer that's missing.
Yeah, there's two washers on the floor,
Oh, there.
fancy valves.
These are expensive. You can't bring them, so they're special studies. So I'll premix some polyester resin, and I've added in black pigment just to. You see the black there? Just chuck in some. Okay, this one. 2%. 1.2, so that's 24.
Clearing go 4%. Clearing go 4%. Enduredge.
30. I've had a customer have bags for making pool filters. Unofficially sitting at about somewhere around 2,500 bags already. Pools. And it's got one size bag for two size filters. So the bigger one either stretches it. It's getting to the end of its life, but it's still really is working. I'm making a lot of bag these days where there's actually no resin inlet. It's the right size. Just chuck the mix inside, chuck the bag on and pull. And
Well, after a few pulls, you'll know how much you need.
Oh yeah.
yeah, the one I was making air freight crates, so 1.5 long, 800 high, 600 wide, and he was using 8.4 kilos of resin every time. Exactly. Once you work that out, it's perfect. And he chucks all the resin in the bottom, and then they just with a roller just push this bubble of resin around where they want it to be, and it fills every time. It's very seldom that there's a spot that doesn't work so well.
Right.
Did you offset with sheet wax or did you offset with pipe?
Yeah, this is offset the sheet works. And I don't know how much resin I'm putting in this. Deviate. Actually, my diffuse very quickly now, so we'll go there, we'll go into that one. So I'm sucking this line up. Actually, vacuum's working.
Yeah, live demos. Again, this technology is absolutely available, and Brian is there to support you guys in manufacturing these types of bags.
We put it through that. Okay, so I've done this one up. So you can see there's flow happening up to that. It's right up to that point. And I'll get the flow down up to this cross section here. I don't know if you can see it there. See the black line there, so resin's been sucked up into that. So that runs back to there. I'll do this line, so do this one here. Start seeing stuff up there. I'll do that one. Just a little black ribbon to
How long has it been infusing, Brian? 2 minutes now?
2 minutes, 3 minutes. Do this last one here. Into there. To that side. See this over here, resin starts flowing up this line. Start waiting out there. So then if I do this for you. Let's see, that's created the flow line there. is very nice.
What was the material you put in there? Just chop strands?
2 layers of chop, and then I had some funny combi mat stuff, which is about a 2,000 gram woven roving with a chop to it. So 3 layers of chop and a 2,000 gram woven roving. It's fun something. And we chucked in 1.2 kilos of resin. This is just a laminating resin that I added 10% styrene to.
So it's a bit thinner.
Yeah.
If you just put roving core in there, would you still need all those?
No.
Not like what we do, just it flows so quickly.
Yeah. So you can see over there. I think we might have run out of resin.
I'll show the final part.
Yeah, I'll show you the final part. So this is the previous part that I made. And that was 4 layers of 450 chop. So we just trim the edges and done nothing else to it.
And the surface, just a gel coat.
Just gel coated, 4 layers of chop. So I was surprised how nice and smooth the inside surface was. Yeah.
Brian, would you be ready for the
What's our time now?
level?
11. Another 15 minutes of chop.
All right, so are there any questions around this? No? Okay. So what we do have is we have the Prepreg almost cured. I think we could have a little bite outside, and then if you wish, we will cool it down and demold. Are there any questions in the interim? Okay. Great stuff. Sorry, Nige, just check if okay. Yeah. All right, so we can share some questions outside as well if you wish.
Well, the original soda thing is now.
It's not that good.
No, that's
Okay. Thanks very much. Thanks.
Commercial delivery van there.
Are we done? Had some